so we're going to continue the video. I'm sorry that it cut me off and I don't have time to re-record from the beginning. So we left off over here with my two intercepts already graphed, and we're trying to determine if this was continuous or discrete. So we're talking about volume. I have 600 gallons in the tank. As time goes by, those gallons are decreasing, right? They're going down at a rate of -15 per minute. So from 600 to the next one, right, you have to go through all of the numbers possible from 600 to the next amount of volume in order for it to get there. So every single number between, in this case, 600 and 0 gallons, all of that volume needs to go through physically for the tank to get to 0. So because of that, every number in between coordinate points would be used. So this is a continuous function. So now that I know that it is continuous, now I can make my line. So I'm sure it's continuous now. Okay, so I will go from here and draw my line. Okay, so this is what the function would look like on the graph. So I've done letter A. Now I have to find domain and range for f of t. So the domain will be in minutes. And this whole experiment of the tank getting empty goes from 0 to 40 minutes. So from 0 to 40 minutes is my domain. Here you can put t for minutes, right? And it's going to be less than or equal to 40, okay, because 40 is included, or greater than or equal to 0. So that's my domain. My range is the gallons. Okay, so in this case, f of t, which is the gallons. Okay, and then in here, I go from 0 gallons to 600 gallons. So from 0 to 600, less than or equal to 600, but more than or equal to 0. So less than or equal to 600, but more than or equal to 0. And that is my range. This is domain, this is range. Now I have to evaluate f of t for 420. So what is the value of t when I have 420 as f of t? So I copy my equation that they gave me at the beginning. So f of t equals 600 minus 15t. Okay? From here they're telling me, excuse me, they're giving me the f of t. So this part right here, I know it's going to be 420. Okay, so they're giving me the number of gallons here. When the gallons are 420, what is the time that happens when the gallons are at 420? So now we just need to solve the equation. Okay, and then here we will have 180. I'll do it over here on the side since we ran out of room. So negative 180 equals negative 15t. When you have different signs, you subtract and keep the sign of the largest. And then here I'll divide by negative 15, and t equals 12. This is a context of the problem situation, so I need to explain it with what's happening, the situation in the problem. So that means that when at time or after 12 minutes, there are 420 gallons in the tank. So I'll just say that after 12 minutes, there are 420 gallons. Okay, that's what it means in the context of the problem. And here would be minutes. Those would be my two answers. Evaluate f of 10. So this goes back to what we learned a couple of days ago. I take my original equation, f of t equals 600 minus 15t. Okay, and now I have to evaluate for f of 10. So instead of the t, I'm going to substitute 10. So 600 minus 150 would give me, excuse me, 450. Okay, So now I have to evaluate, or what does it mean in the context of the problem? Here f of 10, 10 is in place of the t. So this means that at 10 minutes, or after 10 minutes, there are 450 gallons. In the tank. So these two would be my answers. This would be gallons. Okay? Interpret f of 0, evaluate f of 0 and then interpret. Every time you see interpret, it's the same thing as like in the context of the problem, using the situation. Okay, so here I have f of t equals 600 minus 15t. Now I'm evaluating for f of 0. When I do that, I realize, wait a second, I already evaluated for that, right? So I already got, in this case, I'm making t 0, and I already did that when I got the y-intercept, right? That's 600. So what does this mean in the context of the problem? Well, at 0 minutes, there were 600 gallons. Or in other words, at the start of the experiment or the situation, there were 600 gallons. At 0 minutes, the start, there were 600 gallons. This is actually my y-intercept. If you have problems interpreting, whenever you evaluate, put it in a coordinate point. For example, for letter E, if I were to put this in a coordinate point, right, there's the 10 is in place of t, that's my x, and then I got 450. Okay, use the graph to help you. Wait, 10 is the t or the x, so that's minutes. You will label here minutes. 450, according to my graph, the y is number of gallons. Once it's in a coordinate point and you label which is which, then it's easy to say, oh, at 10 minutes there's 450 gallons. Here the same thing, if you put it in a coordinate point, when x is 0 or t is 0, you got 600. You know that x or t in this case is minutes, and the 600 is gallons. Once you have it in a coordinate point, it's easy to write the sentence. Oh, at 0 minutes there are 600 gallons. Okay, got it. Okay, on the next one, you have to evaluate f of t equals 0. So I write my original equation again. And now f of t, so all of the y value, all of this would be 0. When I substitute, I remember, oh, I already did that initially. This is that. I made f of t be 0, and that was actually the x-intercept, so I should get 40 when I do that. Divided by negative 15, t equals 40. Okay, so what does this tell me? When the time is 40, f of t, or gallons, is 0. You can write it as a coordinate point, right? T is the x, and you made f of t or the y be 0, just like before. This is minutes, this is gallons. So as a sentence, you can say at 40 minutes there are 0 gallons in the tank. Or you can say it took 40 minutes to empty the tank. It took 40 minutes to empty the tank. So either of those would be acceptable, or both of those would be acceptable. Alright, so we're done with that problem. We're going to go ahead and move to the back. Over here, we need to find a domain and range for each of the functions. Every time you're asked to find domain and range for anything, whether it be a graph or a word problem, you need to determine if it's continuous or discrete. Okay? So when you read the problem, you're talking about a car that's traveling 32 miles for each gallon of gasoline. Okay, so 32 miles per gallon. And then here is the equation. D of x is the distance in miles the car can travel, and x is the gas. Okay, so now you know what the Y is and what the X is. The car's fuel tank holds 17 gallons. So domain is your X, and this is the gallons. Your range is the Y, and in this case it's miles. So for this whole experiment, you need to know how many gallons it took, and then how many miles it took. So here it is, a very important piece of information. It says that there's only 17 gallons. So whenever I write my domain, I know that my highest number can be 17 and my lowest number is 0. It's either an empty tank or a full tank, right? So from empty to full, that's from 0 to 17 because that's the most they can hold. Now I just need to know if this is a continuous function or a discrete. So then you fill up the gas tank, and then in order for you to go from the 17 gallons of full tank to like the next like 16 gallons, you need to, that volume, all the numbers between 17 and 16 have to physically go through that volume so you can get to 16. From 16 to 15, you have to have all of those volumes in between to go from that to that, right? So you don't jump from 17 gallons and all of a sudden 1 gallon disappears and then you go to 15 or whatever. So all of those have to go through. So this is a continuous function. Now that I have decided that, I know that my domain will be in inequalities. My domain over here, X, is in gallons. And like I said, they're telling me of gallons. So we know that it goes from 0 when it's empty to 17 when it's full. So that would be my domain. For range, I need to calculate now. I know that it can go from 0 miles, right? That would be the least amount of miles it can travel. But now I need to know the most amount of miles. I already know that this can be 17 is the maximum gallons. So in order to find the maximum miles, I need to know how many miles a car can drive in these 17 gallons, what the distance would be. I'm going to have to use my equation. When I have the maximum amount, when the tank is all the way full, that would be the maximum miles I can travel. So I have to multiply 32 times 17. And that gives me 544. This is the maximum distance when I have a full tank. When I have an empty tank, I can't go anywhere. When I have a full tank, I can go all the way to 544. Okay? So now I have my domain and range for that. For the second one, we're also looking for domain and range. So again, I need to know if it's continuous or discrete first, if I'm going to evaluate domain and range. So this problem, we did it before when you had to graph it. It's in your packets. But this time you don't have to graph it. You just need to decide domain and range. The equation is 2x plus 4y equals 320. Okay? And it says here that x is the student tickets, of student tickets, and y is the number of adult tickets. I need to decide if this is continuous or discrete. So if I'm selling tickets, I cannot sell any tickets in between 0 and 1. Like either I sell 0 or I sell 1. All the numbers in between 0 and 1 cannot be tickets sold. You can't sell partial tickets. So this is a discrete function. Okay? So now I know I'm going to have to list it. I'm going to have to list the minimum amount of tickets I can sell for students and the maximum, and also for the adults. I know that for both, I'm going to start the domain at 0 because you can sell 0 student tickets. You can sell 0 adult tickets. Now I just need to know what the maximum number is. Okay? So here, if I sell, to find out what's the maximum amount of student tickets, and you did this in class, what's this is for? Okay, remember this is my student tickets. I'm going to say that I didn't sell any adult tickets and only student tickets to see what the maximum would be. So in other words, finding the x-intercept. If I only sell student tickets, then I need to sell 160 of them. Okay? So my domain would be from 0, right? 1, 2, all the way, and I can use, actually I can only use 3 dots, not that many. 3 dots, and then all the way to 160. So I can do this. I don't have to waste my time listing every number from 1 to 160. It's going to take me forever. But I can show it's discrete by like writing a couple of numbers, putting 3 dots in between, and then putting the last number. Okay? So, and that's discrete from 0 to 160. This is if I sell none of them, and this is if I sell just student tickets. I'm going to do the same thing with this. This is if I sell more adult tickets. Now I want to know what is a number if I sell just adult tickets and no students. So I cross out the student tickets. Results 0 in this situation. So in other words, your y-intercept, and this would be 80. So here I can write a couple of them, put 3 dots, and then 80. This means that all the numbers in between, as if I had listed them until 80 would be the last one. Okay, so I don't have to write every single number. So that would be my domain and my range for that situation. Okay, we're going to go ahead and go to the next part. Identify the relations are functions or not functions. If they are functions, each input has one output. Okay? So over here I notice that 1 has an output of -3 and an output of 3. So this is not a function. Over here that the input of 3 has an output of 1 and an output of -1. Not a function. Over here each input has an output. This one, even though the output is the same, it's okay. If I were to do it in a mapping, right? Like if these were a mapping, all the arrows would point to that. But this would be like the Taylor Swift and Ariana Grande situation, which we discussed in class. All of these performers can perform at the same spot. It's okay, that could happen. However, here would be like the Beyonce problem. Beyonce -1 at the same time. Cannot be at 2 places at once. Cannot be at 2 places at once. This, yes, you can. All of these can be at -4. So this is a function. When you have it as a graph, same deal applies. Each input has one output. Okay, in order to prove that, you can do a vertical line test that we discovered in class. Okay, we draw a line through wherever. This input of 1 already has an output of 1 and an output of -1. So, not a function. Okay, Beyonce cannot be in 2 places at once. Over here, it looks like every single input has only one output. Okay, so this is a function. This one looks like the Beyonce situation again. Here's Beyonce, my x value, and it has 2 different places or 2 different outputs. Okay, this one, 1, 2, -3 has an output of 3 and an output of -3. So this is not a function. Okay, although this one is listed, and now we look at all my inputs, and it looks like this is a function. None of them are repeated. They all have different outputs. And look at these 2. And I don't see any, let me double check, that repeat here either. 4, -3, 9, 2, -4, here it is, 2. So 2 looks like it has an output of -1 and an output of 7. So 2 has 2 outputs. This is not a function. Okay? Now we have real life situations and we have to determine a person and his or her birth date. Okay? So here many people, let's say like Mary and John and I don't know, Jose or whatever, have the same birthday. Let's say October 1st is their birthday. So all of them would be, if this were a mapping, Mary, John, and Jose, right, would all point to 10-1, right? So several people can have the same birthday, Okay, so that means that this could be a function. First name and last name. Okay, so let's say that Jose has a last name of Perez. Mary can also have that last name. Okay, however, first names are not exclusive unless you have like a super unique name, right? But there are many cases where names are repeated. There can be another Jose, there can be another Mary, right? And that Jose and that Mary have different last names, like Gutierrez or Smith. Okay? So now you have Jose and Jose. Jose goes to Perez and also to Gutierrez. Mary goes to Perez and also to Smith. Okay? First names can be repeated in the population and have different outputs because each person has a different last name or could have the same or whatever. So this would be not a function. City and zip code. This one, for example, McAllen. Okay, McAllen has different zip codes, like 78501, 78503, 78504. Okay, so over here, McAllen, right, this input already has 3 outputs. Bigger cities have way more than that, so this is not a function. Last name and first name. This is the same deal with letter B, right? You can have a, last name of Castillo, right? And then you can have Castillo go to like Joe, and also a person named Priscilla. Now Castillo already has 2 different outputs, and it can have many, right? So this is also not a function. Alright, for this one, domain, range, function, or not. So if they're listed points, this is going to be discrete. Your domain is just going to be your x values, 3, -2. Okay, but let me list them first. 3, -2, 3, and -2. Remember, for domain, you can't repeat, or for range, when it's discrete, you have to write them only once, and in numerical order. So -2 and 3 would be the domain for this. Okay, the range, you have -2, 3, 1, and 0. They're all different, so I'll just list them in numerical order. So here would be -2 first, then 0, then 1, and then 3. So that would be my range. Function or not a function? So it looks like 3 has an output of -2 and 3 also has an output of 1. So one input has 2 outputs, so not a function. Okay? This one, the domain is already in alpha order, and these are discrete if they're like this. So 1, 3, 5, and 7 would be my domain. My range is already in numerical order, -1, 4, and 6. It looks like every input has its own output, so this is, yes, a function. Okay, over here, my domain, I put it in numerical order, 0, 1, and 3. My range, I put it in numerical order, -2, -1, 0. It looks like 0 has 2 different outputs here, so not a function. Okay? Alright, I'm going to stop the video here and then make another video, that way it's not like super lengthy. So I'll see you in the other video.